For today's lesson, we're in section 7.3, talking about double angle and half angle formulas. Here, I've stated the double angle and half angle formulas for you. They are also in the book on page 508 for the double angle, and I believe 510 for the half angle. If they're not on 510, they're on 511, one of those two pages. But here I've stated for you so you can pause the video and write them down at your leisure. So here what we're going to do is we're going to use these formulas to help us evaluate and find either exact values or things that are close to exact. So example 1, they want us to find sine of 2x, cosine 2x, and tangent of 2x when sine of x is equal to 2/3 in the first quadrant. So what I first need to do is I need to figure out what the rest of my triangle is, so I know what my cosine and tangent are, because I need that adjacent side. So here, opposite side is 2, hypotenuse is 3, based on this figure. I'm in the first, so cosine is also positive, so I'll need to solve using Pythagorean theorem for that side. So it gives me 9. X squared plus 4, subtract 4, and then I'll square root, and like I said, it's positive in the first, so this will be a positive square root of 5. Okay, so now that I have my ratios, I'll be able to find my double angle identities. So first let's start with sine of 2x. Here it's 2 times sine x cosine x. So in this case, 2 times the ratio of 2 over 3 times square root of 5 over 3. And so then, remember this 2 over here is over 1. So then 2 times square root of 5 is 4 square root of 5. And then 1 times 3 is 9. So then that would be my ratio for sine of 2x. And then cosine of 2x. Now here you have 3 identities. You have cosine squared x minus sine squared x, 1 minus 2 sine squared x, or 2 cosine squared x minus 1. It doesn't matter which one you use, so we might as well just use the first one. So cosine squared x minus sine squared x. So here insert your cosine and square it, and the same for your sine and square it. So cosine was square root of 5 over 3, and then sine was 2/3. So squaring those gives me 5 over 9, and then minus 4 over 9. So then that gives me 1/9 for my ratio. Okay, and then the last one we need to do tangent of 2x. Okay, this one will be 2 tangent of x over 1 minus tangent squared of x. Now here, my ratio for tangent is going to be 2 over square root of 5. Okay, so I'll insert that in. Okay, so as I get 2 times 2 over square root of 5, that'll give me 4 over square root of 5. And then on the bottom, I get 1 minus, and square the top gives me 4, square the bottom gives me 5. So here on the bottom, I need to make common denominators so I can put my fractions together. So it gives me 5 minus 4, which is 1/5, so I'll spare you that. And then I'll multiply it by the reciprocal. Okay, so then that gets me 20 over square root of 5, but we'll need to rationalize here. And then I can also reduce. So that gives me 4. And that gives me 1. So 4 square root of 5 would be my ratio. Okay? So then that's how I find each of those. So I would have 3 answers. The other example, we're using half-angle identities. All of the half-angle identities are exactly the same in how you use them. So basically, if I need to find half or the sine of 15, I'm using the sine one, but what I'm trying to do is what value divided by 2 gives me 15. Okay? So I need to find a x value that fits this category, which would be 30. So that's my x in this case. So then now I'll use 30 in my equation. So notice that I don't use 15 for anything. So I start out with the equation of 1 plus or minus square root of 1 minus cosine of 30 over 2. Okay. So here I want to insert what cosine of 30 is, and that is square root of 3 over 2. And then I need to make common denominators with the top. So it gives me 2 minus square root of 3 over 2, and that's all divided by 2. Now that's the same thing as over 1, so in the next step I'm going to multiply by the reciprocal. Okay, so then I multiply across. It gives me 2 minus square root of 3 over 4. Okay, now here with radicals, to simplify it if I can split them up into a top radical and a bottom radical, because I notice that 4 is on the bottom and 4 is a perfect square. So then simplifying, I'm left with 2 in the denominator. Now, the last bit is to worry about this plus or minus. Okay, so which one is this? So I look back at sine of 15, and I think, okay, where's that in the unit circle? Sine is 15 in the first quadrant, and first quadrant is positive for sine, so that must mean that my ratio is going to be positive. Square root of 2 minus square root of 3 over 2. So I can drop the negative at that point. If, let's say, our angle to begin with was in the third quadrant, like we got sine of 200, so therefore that angle's in the third, so sine is negative in the third, so that means that we would have negative square root of 2 minus square root of 3 over 2 in that case, if that was our angle. Okay? So that's how you kind of manipulate double angle and half angle identities. Have fun.